Hello everyone, a very good afternoon. I would like to thank you all for joining us today. My name is Aparna and I'll be hosting this webinar. Before we get started, please let me take a few minutes to introduce Payatu. We are a research-powered cybersecurity consulting firm with a decade-long track record with a singular focus on cybersecurity. The foundation of Payatu rests upon three pillars: community and conferences, consulting and training, products. Community and conferences encompass NullCon, an international security conference training and exhibition platform. Hardware.io is a hardware security focused conference along with other initiatives. Consulting and training focuses on thorough security assessments, which helps businesses to discover security threats and further provide training to strengthen their network infrastructure. Lastly, we have three offerings: IoT Auditor, an IT security testing and compliance platform. Exploity is an open source IT security testing framework. Exploity Academy is a comprehensive online learning platform that empowers professionals with the knowledge and skills to excel in the field of cybersecurity, particularly in the context of securing IoT devices. Here is an overview of the various consulting assessments we are known for across the globe. Payatu has delivered many cyber talks and workshops in top security conferences that include Black Hat and DEF CON. We take pride in the decade-long impact we have created by contributing to the cybersecurity community all around the world. Recently, our Payatu community has migrated to Telegram from WhatsApp. This is due to the member cap set by WhatsApp, because of which only a limited number of people can join the community. For those unaware about our community is a platform meant for fostering knowledge sharing and collaboration in the cybersecurity realm. With this community, we aim to educate various organizations with industry-specific cybersecurity content. For those curious about Payatu hirings, these are the openings currently in our organization. That was all about Payatu. Today, Samuel, Payatu's security consultant, will deliver a webinar on Docker and Kubernetes security. You can read all about him on this slide. Before I hand it over to him, I request you all to follow a few housekeeping tips. Please be on mute. If you have a question, you can write it in the chat box. We'll answer the questions at the end of the webinar. The recording of this webinar will be released on our digital channels, so make sure that you are following Payatu. If you are not currently following Payatu, please check the links provided in the chat box to find Payatu's digital channels. Without further ado, let's get started. Samuel, over to you.
Hey everyone, hi. Thank you so much for joining in. Today I'll be delivering a webinar on Docker and Kubernetes security. It is great to have all of you here. Docker and Kubernetes is something that is vastly growing and majorly is important for a security point of a perspective. A lot of us might be aware of what Docker is and maybe not be aware of what Kubernetes is, and maybe might have a lot of you might be aware of both of the things. But when it comes to the security aspect of these both, somewhere or the other, a lot of enterprises a platform also lack into this. Today we are kind of aiming to get a dive into this and maybe understand how things work from a security perspective. So let's discuss the agenda of the call. So we'll be going through the introduction of all the things and the takeaways from the session of what you're gonna learn and what you can be expecting from the session. We'll go through a brief info of what is Docker. For people those who are new to this, what is Docker and how a Docker architecture works. We'll also be going through the best practice and security aspects according to the OWASP top 10 list, where there are top 10 vulnerabilities listed, which is vulnerable in Docker. Uh, uh, Furthermore, we are also gonna maybe convert this into a demo, and I'll try to explain you how things can be exploited in a Docker and a Kubernetes environment. Same goes with Kubernetes. What is the relationship with Kubernetes and Docker? How things work hand in hand? We'll be exploring that as well. Furthermore, we'll be going into Kubernetes and its exploitation as well. And We'll also go through the some real world scenarios and case studies which has happened. Maybe the misconfiguration of a Kubernetes cluster has led to a lot of mishaps. So we'll kind of cover some of the real world cases as well. I hope we all are ready for this. Session takeaways, we'll kind of go through building a simple Docker, a simple maybe an HTML page. We'll see how the process works into forming a container, forming a Docker, and also I'll be taking you through how to create a Kubernetes cluster. Also, we are gonna test those as a lot of time on the production environment or in an enterprise level entity, we don't use Docker directly or Docker as a single entity. We integrate that with K8s, and that is how we have a clusters of containers. So we are going to go through how we can maybe use a standardized testing method. Also, we'll be seeing some few scenarios on the demo part. We'll be seeing few scenarios as well, where in the real world scenarios, what mistakes happened from the developers from the DevOps team. We'll be exploring that and exploiting it. Also, we'll be talking about how to mitigate it. We'll be talking about methods that are there that should be implemented to avoid these things to happen. Something about myself. Hello, everyone. Again, this is Samuel Valmiki, also known as Signature. That's my pseudonym. You can search that on Twitter or on LinkedIn. You'd find me. I am currently working as a security consultant at Payatu. I have an experience of over 3.5 years. I have specializations in several areas, that is web, mobile, source code review. And recently, from a couple of months back, I have kind of started an interest into DevOps, where I kind of understand the backend more and better. That helps me find good bugs as well. A lot of you might resonate with me because understanding level development process is something that helps a security researcher. Also, in my free time, I do some bug bounty hunting as well. Where I have secured a lot of companies. You can check out my HackerOne profile as well, with companies like Apple, Zomato, Blinkit, which was known as Grofers earlier. So all these companies I have been searching bugs for and getting some bounties and doing it for fun. Also, I something that I like is to develop things on a security aspect note, where I like to develop tools. There are a couple of tools which I'll be dropping in a couple of months. It is underway. So yeah, I am right now kind of dedicated to maybe learn about Web3 security. This is something that I have got interest into, and this is kind of what the Web2 is going to convert into the Web3. So this is something that I feel everyone should be maybe learning about and should be keen to learn. So currently, this is what my interest is. Without further ado, let's dive into the Docker and Kubernetes. Let's focus at this area. So let's see some statistics. Docker and Kubernetes, right? Docker and Kubernetes. Let's talk about Kubernetes, which ultimately, when you use Docker, you are gonna end up using Kubernetes as in a company or in an enterprise platform. So talking about Kubernetes, it was previously handled by Google, and right now it is kind of handled by CNCF. This is a very great summit of people where they focus on enhancing cloud security, enhancing cloud features, and kind of stuff. So, according to the survey conducted in 2020, there was a very high spike of people shifting to Kubernetes and adopting Kubernetes as their cloud platform. More than 70-80% of hike was being seen, and it is projected by 2027 more than 80 to 90% of the enterprises will be using Kubernetes. Why so? Because Kubernetes has a lot of features to offer. Some of them to mention is auto scaling, auto healing, and service discovery, and a lot of great features that Kubernetes has in itself. Let's kind of dissect it and kind of start it from the beginning and try to understand what is Docker. Let's go with the textbook definition that we have over here. Docker is an open source platform that automates the development, scaling, and management of applications using containerization. You should be familiar with this word, containers and containerization. We'll be using this a lot in the call. Containers allow developers to package an application with all its dependencies like libraries, system tools, and settings into a single standardized unit that can run consistently across various computing environments. To put it in a way, this is kind of a box. I have also kind of summarized it in a layman term where it says it is kind of a virtual box where you only have stuff that you need, and the other thing that is not needed is not included in that box. Only the things that your application need is included in the box. Suppose you have an Python application. Suppose let's take an example of a static web page, right? And that static web page has an maybe an SIP calculator, right? So you won't need a lot of stuff to on your application. Your application was most of it will use JavaScript, it will use HTML, it will use CSS, and it won't use much, right? If you are developing a simple calculator, right? And this is where only things that are needed, maybe a web server, HTML, JavaScript, only the packages and the libraries that are needed, only those things are kind of put in a box, and this way you can actually run your application. Also, this box is called as a container, which you can take it anywhere. Take it to your friend's place, and it will work there as it was working in your system. So Docker solved a very big problem that developers had initially. This is a term that developers use a lot, saying this works on my system. In the sense, there was a lot of time where developers used to develop something, and after maybe sending it to someone or maybe asking someone to access the application, there used to be a lot of crashes, and a lot of things you would not work as usual or as expected, because the person who used to access the application, maybe he didn't have the correct dependencies, maybe he didn't have the correct version of the library that is being used. So to kind of solve this, Docker was put into place. Containerization was put into place where you have all the libraries, all the packages that you need. Suppose your simple calculator needs an server version of suppose 1.1, and the other person is having web server version of zero point 0.1 or something. The Docker that you share with him will still work because this is having all the things that the application needs to run. So this is something that Docker solved, and you should be familiar with this, saying this is kind of a container where you can take it anywhere, and the logo itself defines the same thing, where it is simply a very easy method to take your applications anywhere, host it on your cloud service, host it on your bare metal or anywhere. So let's learn about what is the difference then between Docker. You might ask, right? What is the difference between a VM and a Docker? It is both kind of working in a similar way. So if you wanna kind of you have a Windows host machine and you want to run Linux over it, what do we do? We have a virtual machine. What does it do? It makes a virtual machine. It makes a virtual section and isolation where you will be able to kind of run Linux environment on it, right? So what is the difference between both of them, the virtual machine that we had before and Docker, where everything is kind of getting migrated? So let us understand with some example that we have on the screen. So infrastructure, right? This is something you would be expecting a virtual machine architecture, and this is the Docker architecture, a containerized architecture. So this is the infrastructure, which is kind of the bare metal or a cloud instance or anything, which will have an hypervisor. This is a middleman to take the resources from the kernel, and the hardware access will be managed by hypervisor. And then you will have several virtual machines. So suppose we're talking about a web app or a static web app, SAP, a single page application, which needs to be hosted on a virtual machine. So why do I need to host it in Docker, and why should I not host it in a virtual machine? So virtual machine worked in a way where it needed to have an operating system, a guest operating system, and on the guest operating system, you will then install your application, all the packages that you need, all the libraries that you need, and then that particular application would be accessible. So, what is wrong over here? The most biggest problem with virtual machine was it was resource hungry, meaning the guest operating system, even if you host and Linux system, right? It would at most need 3 to 4 GB of storage to let the operating system run. It would need a particular amount of RAM to run, and a lot of things, a lot of resources were getting used, and it was difficult to host a lot of application, because if this particular host machine, this particular guest machine is kind of using 2 GB RAM, and this particular guest machine is again using 2 GB. All the three machines combined together will use 6 GB of RAM. And suppose the main infrastructure, right, the main host OS is of maybe 8 GB, or maybe 12 GB or 16 GB. So in that case, it will take a lot of resources, and leave the host machine maybe with lesser resource. Also, a single SAP, a single page application, won't need all these um, packages or all these operating system things that you have, right? So to solve this, Docker was introduced, a containerization was introduced. What happens over here? Again, it's the same thing. There is a bare metal or a cloud instance, and you have the operating system above it. And operating system will manage the Docker. So there is one extra entity over here, which is Docker. What Docker will do is Docker will actually behave as a middleman and not create OSs. As you can see over here, there is no operating system over here. Why so? Because Docker will make sure any resources that is required from an OS or from the host machine, it will provide it. So Docker will be using all the resources from the host machine, may it be network, may it be storage and stuff like that, and it will use the host operating system, and only the packages and only the libraries that are needed will be in this container. So you can see the amount of containers, the amount of application has increased as well. So here, this particular container has my server, has my maybe the HTML file, the CSS file, and maybe the JavaScript file. Only three of these files are needed on, and maybe rest of the dependencies. Maybe you're hosting on it on a Node.js or Nginx or Apache. Only resources that are needed is now combined in a box, that is this container, and this can be now run on the system. Any resources that it might need, it will take it from here and then run accordingly. So this solved a great problem, because imagine if you are on an enterprise level, and you are paying for all these virtual machines, right? So just for hosting three applications, maybe not that huge, or just on a micro level. um, you are paying for all these three virtual machines, but here you just have to pay for this one virtual machine. And if it's in kind of a micro application, it can suffice multiple application in just one system. So this is something that is called as containerization, where Docker won't be installing an OS, but you will be using all the OS requirements from the host machine, and all the library packages that are needed and the file that is needed will be kept in this container. This solved a great problem um, of uh, of containerization, of virtualization. Both of them are doing the same thing. It is virtualizing stuff, but Docker does it in a better way, in a better resource consuming way. So this is something that everyone should be aware of a difference that Docker brings into place. Let's understand what is the architecture. How does this Docker, right? This particular middleman is doing what the middleman is doing over here. So there are some commands like Docker build, Docker pull, and Docker run, and this is the main middleman, also known as Docker daemon, and this is kind of a registry. Registries are a place where you have images. So as you have an iOS image, right? Sorry, ISO image, right? Where you have the whole operating system with all the packages, all the libraries. Even if you don't need some of the stuff, still it is there. So Docker has created a registry where it has a lot of different variants of these registries, these images, where you can get whatever image that you require. Just you can pull out that image to yourself and create a container for that. So suppose, let's take again the example of the SAP that we are talking about, a single page application. So I just need Nginx for it, right? We just need Nginx. So what I just say, hey Docker, pull the image Nginx from this Docker registry and make a container for it and put these two files in it, maybe three files, the HTML, CSS, and JavaScript. What the client is something that we interact with, the CLI that we interact with. So Docker pull, what it will do, it will command the Docker daemon. Docker daemon will then go and fetch the image from the Docker registry. This is just the Nginx package. It won't have anything else like the traditional Linux. It maybe has find command. It has an apt. It has an sudo, and all these things are there in an OS, right? If you just install this image, you won't have any of those stuff. You will just have the image. So once the image is downloaded over here, it is kind of a local registry that you have in your system. It will just pull that image over here, and all the files that you mentioned, the three files will be then added to this container. Nginx will be added to this container, and this container will then go up and running. What does this mean is this already packaged everything, all the things that were needed, and it will kind of host. We'll be seeing this in the demo quickly. So this is a kind of what it how it works, right? So Docker build, you build a Docker file, and then you kind of Docker pull. Docker pulls the image that are required, and then it runs. So let's quickly see some security aspects and the OAuth's top 10 list that we have, and quickly jump to the demo. So as can be seen over here, Docker security and best practices. These lists that are on the screen is from the OAuth's top 10. So OAuth is an organization which releases top 10 vulnerabilities of every tech stack, and that is kind of on your screen. So these are all the stuff that needs to be definitely configured properly, that you and I don't misconfigure a Docker or a Kubernetes cluster and let something bad happen, let a breach happen or something like that. So as you can see, it is clearly as it says, like it is clear up to the word, keep the host and the Docker updated. Sometimes it happens like the Docker is not updated, or maybe the host is vulnerable, and it happens that due to this, maybe there's in privilege escalation. The hacker is maybe able to go from the Docker to the host. Do not expose the Docker daemon socket. This is something that we'll be looking into. Expose the Docker daemon in the sense, the last slide we mentioned. Docker daemon is something that controls everything. So for remote access, a lot of developers, what they do is they expose this Docker daemon to have a remote connectivity to it, and exposing this is very dangerous without proper configurations. Then it comes to set a user while building, not to go with a root user. Limit capabilities. Capability in the sense, Docker says what things can you access from the host. So this is the middleman, right? So while accessing the resources from the host, it should be limited with capabilities and inter-container connectivity. Suppose you have two containers, you have one container for your front end and other container for your back end. So you should have a isolation between them. The both should not be able to connect to each other because maybe one of them is a crucial, the backend system is a crucial system. You should have a proxy or something between. uh, you have a Linux security model. These are some of the default Linux modules that are present. You just have to configure it, limit resources. So suppose the application might not use that kind of resource, you just have to limit it to that particular maybe the RAM, maybe the file system. Set file system volumes to read only. When there is no write to your volume, it has to be strictly set to read only. Integrate container scanning tool. So there are a lot of times where there is a vulnerable container. So as I mentioned over here, what happens is Docker registry is somewhere that not only Docker, you and I can also maybe put our custom images over there. So a lot of custom images that are there on Docker Hub, they are actually vulnerable. They are having a reverse shell to their systems, which actually gives control, which we will be talking about this in the real world scenarios that we will be discussing later. Run in rootless mode, use secrets for sensitive data management, enhance supply chain security. So these are something that I highly recommend. This is very clearly explained in the OAuth top 10 list. Please kind of review it, and it is highly recommended to go over there and go through the detailed explanation of each of them. Let's quickly go on to the Docker demo. We'll be shortly building a simple Docker. This can be seen. This is a Docker file for a simple web application. As you can see, this is just we write from Nginx Alpine, meaning we say Docker daemon, pull the Nginx image, and then from the Nginx image, once it is pulled, I have an index.html file in my system. You just copy that index.html page to this particular directory, which is the directory of Nginx, and then expose this particular port. And then this command is to run. This is just a simple Docker file, and that's all it takes to run a Docker. That's the beauty of Docker. And this is the HTML page. These are some of the commands that will be useful. Docker build your HTML page, Docker run, and we can just map the port to it. And this is our container name. These are some useful commands that we should be aware of. So let's kind of start with understanding how things work. I'll be powering on my Kali. So yeah, let's first see how a Docker image is built. I hope my screen is visible and correctly shown. Okay, so let's quickly look into this. So I'll be navigating to a directory that I have. So you can see there is a Docker file already created. Let's view the content of this Docker file. So if you view the content of the Docker file, it is the same thing from blah, 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 from the Nginx image, get it, run, remove everything that would be in the Nginx directory, and then copy this particular HTML and expose this particular port. Once this is done, you can just simply run the command saying, hey, Docker. So whichever directory your Docker file is in, right, you just have to run this command, Docker build the image. I already have the file over there. Build it and maybe name it test. And then where is my kind of the Docker file? You just have to say it is in the current directory. This denotes the current directory. So once you just do this, it will send all the context that it needs to send. It will kind of uh, get the Nginx file, and then it says secret. Okay, just I need to change. There is no secret HTML. I can just delete that, save it again, and build it again. So there was an error because index secret was not there. That there was something that I was working on. So yeah, see, it says it was completed and successfully tagged as test. So to view what are your containers, you can just do a running containers that are there is Docker PS, which will list out your running containers. Just a sec. Docker. Okay, so we did not run it yet. We just built the Docker. So you can view that as well. So the image is built right now. So we can just do just a Docker image, and you can see this is the latest Docker image that we have built. To run this, we usually do a Docker run and the tag name that is there, test, sorry. And after running this, you can run this in detached mode, but kind of if you don't want the screen to be visible, you can just supply one more flag that is detached mode, which will then just give you the Docker ID, the container ID. If you do a Docker PS right now of the running containers, you can see this is the container that is running. It is running on this particular port and stuff like this. So I already have this container running. If I take you through, this is something that has been hosted with Kubernetes. It is integrated. So yeah, as you can see, welcome to a simple web app. This is a page served using Docker. So simple as that, and the Docker HTML file that you wrote, right, that is up and running. So this can be considered as an SCP, as mentioned before. So what is the vulnerability that we will be looking at? What is one of the security misconfigurations that people actually do? So I mentioned the exposing of Docker Debian, right? So suppose I maybe scan a nmap scan, right? So to identify if a Docker daemon is exposed, you just have to do a full port scan to whatever IP address is there, right? So currently it is on my local host. I will be initiating a nmap scan on my local host. This is the standard port for Docker, but you can use a full port scan and do it. So as you can see, anywhere, if you see this, that a Docker port is open, this is serious risk. Meaning they have exposed the main middleman that we saw in our PPT. They have exposed the middleman which we can actually interact with. So to give you a knowledge about what all we can do, we can maybe kind of this exposes an API. Docker has an API. So this will expose it over here. You have to view the info of the Docker, you just have to go for info. Just a sec. Yeah. Info will give you what containers are running, how many containers are there, how many containers are running, and all the stuffs, right? So you can maybe look for containers JSON as well. Containers JSON, yeah. So yeah, this is something that should not happen. So anytime there's an exposing of this Docker daemon, this is very dangerous, and this can be escalated to a very vast scale. So this is something that should not be there. So you would ask me, then how do I remotely access if I want to have that feature? There are a couple of ways, using SSH, using TLS with HTTP. So that is a process of setting up a certificate, and within itself it's a very large thing to do, but it is it is the best thing to do on an enterprise level or even in your local Docker instances, right? So this is a very common mistake that developers do, that during a development process they kind of expose the Docker daemon and maybe forget to close it or something like that. And once you have this Docker port open anywhere, if you find this, that indicates that the main middle person, the Docker daemon which handles everything, is exposed. You can even do a Docker etch with setting the host. That is, in this case, you can go with the IP address as well, and then maybe do a simple PS, which would actually give you the same output as we got in our local system. So this is something that can attacker can access from outside of your network. So this is a very common mistake, a very common misconfiguration that that a lot of developers and a lot of um, DevOps team actually do. So this should be something that you should be looking at whenever you get a Docker port open. That indicates the Docker daemon is exposed, and that shouldn't be the case. uh, I hope this is clear. Let's hop on to Kubernetes, because on a wider note, on an enterprise level, you won't be using Docker directly, as I mentioned earlier. It would be Kubernetes. What is Kubernetes? Let's go with the uh, textbook definition first. Kubernetes, often abbreviated as K8S, is an open source platform designed for automating the deployment, scaling, management of containerized application. It was originally developed by Google and is now maintained by the CNCF. Known for specially auto healing, auto scaling, service discovery, and much more. Kubernetes has a hell lot of features to offer. So, what is Kubernetes? I just want to ask a question over here. If you all can answer me in the chat. Who knows why this is being abbreviated as K8S? Just let me share the screen again. Who all are aware that why it abbreviated as K8S? Okay, great. Abhinav Kishore, that's the correct answer. Yeah, the K8S is because it's K and all the units inside is there are 8 units inside Kubernetes, and just that's it. It is just simple as that. Kubernetes, this word will help you kind of understand it better, because you just need to understand the meaning of the word. Kubernetes is from a Greek origin, which actually means a pilot or a helmsman. If you are aware of the word helmsman is someone who actually turns the wheel of the boat, right? The helms holder. This is called an helm's wheel. So the one that actually, gives the direction to a ship, that is called as an helmsman, or you can often consider that as Kubernetes. So this is the exact thing. This is the exact thing that Kubernetes does with Docker. Kubernetes is like a powerful manager for apps that are made up of many small parts that are containers. So suppose we just had a one SAP, right? So suppose there are thousands of containers. There are hundreds of containers that you need to manage. So this is something that will help you kind of manage all this. It is again a orchestration platform, a orchestration tool. Does it mean? It helps you update, it helps you deploy, it helps you scale. A lot of features that are there in Kubernetes. One of few of them which are mentioned already over here is auto scaling and auto healing. This is something that is very interesting, and what it means is it auto scales, right? Suppose you might have given a container to use only 500 megabytes of RAM, and suppose that particular container needs now more RAM to operate or more memory to operate. What auto scaling would do, auto scaling would auto scale the container, and it would give the resources that it needs. Same goes with auto healing. What auto healing does, auto healing is something that heals the Docker container in case of a Docker container failure. Suppose you have just one Docker container running and people people are booking tickets on it, and due to maybe a DOS attack or something, that particular container went down, or maybe there was an error or a race condition or something like that. In that case, what auto healing would do, auto healing would auto kind of implement a new container when the running container dies off. This is kind of all the very great features that Kubernetes has, and this is something that draws attention and brings all the enterprises to this particular platform. Now let's kind of understand what is wrong with maybe Docker, and why do we need another thing? Again, if Docker had solved the problem, why do we actually need Kubernetes? Kubernetes actually solves a great problem. So suppose you have 100 of containers running, right? You won't hire 100 of developers, or you won't hire 100 of people to actually manage, and kind of that would be a huge business collapse, right? For every container there are a lot of people that are working and to manage and to see how the container is working, if the container is up or not. So this is something that Docker doesn't have. Docker doesn't have a feature to auto scale. Docker doesn't have a feature to monitor, log. So this is something that Kubernetes brought into place. Kubernetes said, okay, what I'll do is containers you can run. I'll help you run on different nodes. I will help you run on these different pods, and I will manage all the things from just one control plane. So as you can see on this diagram, there's a control plane which is also known as the master node, and all the other nodes are the worker nodes. So one master node can actually control tens and thousands of containers that are there. It's the same thing. The containers are run in the worker node, but to manage it, to monitor it, to auto scale it, Kubernetes was put into place. This is something that everyone should be aware of. Let's kind of quickly go through the Kubernetes architecture. As you saw in the Docker demo, the HTML file we built, right? The HTML file, the Docker file we built, we created a Docker file, just created a file with a name Docker file. We implemented just a simple commands, right? Like from this particular image you have to get nginx. You just copy this HTML file and keep it over here, expose this particular port and run nginx, start the web server. So this is something which is a simple process which was used for Docker, right? But in Kubernetes, everything, almost everything happens with a YAML file. So there is a YAML file which needs to be created to create uh, pods. These are called pods. So the section that you see, these are called pods, and these pods will have the containers. These small boxes are your containers, and the blue thing surrounding it is the thing that manages everything. Kubelet will manage how many pods to run, on which pod, which container to run. Proxy will be handling the network aspect area and all these stuff. So also this master node, the API server, everything is kind of connected through YAML file. So if you want to create a network configuration, you need to create a YAML file. If you want to create a container, you have to create a YAML file. You have to create a pod, you have to create a YAML file. Same goes with all the things in Kubernetes. These are some of the components of Kubernetes, and these are in itself a very large topic. If we talk about API server, if we talk about control manager, there are several control manager. Like there are replica set control manager, there is network set control manager which handles network. Replica set will handle how many replicas to make. There are a lot of stuff that is there, but for a start you can just get to know that this is the master node and these are the worker nodes, and this is kind of how the architecture is for Kubernetes. Let's quickly go through what security goes wrong in Kubernetes, right? This is again from the OWASP top 10 list, which is kind of which covers almost all the attacks that are going on around the world. So insecure workload configuration. So you might know this, and you might also agree with me. Most of the vulnerability in the cloud happens due to misconfiguration. Meaning, suppose there was a setting that had to be turned off. You did not turn it off. Maybe the developer did not turn it off, and that by default stays active. And in that case, if that particular setting is active, that creates an issue. So there is a lot of cases where configuration, mostly in the cloud environment, configuration is something that we should always be eager to know if the correct configuration is done or not. Supply chain vulnerability is a vulnerability which we'll be discussing in the real case study, where due to the second one, there was a very big attack done with Kubernetes. Overly permissive RBAC configuration. This is something which is related to role-based authentication configurations, where you should have only correct user roles assigned. Maybe all the other pods should not be able to access the master node, right? So all the other nodes should be isolated correctly. Lack of centralized policy enforcement. What happens in a larger organization, right? If you have thousands of different pods, you have 10,000s of other containers running, and this is not something that is a random number. This is actually something that actually happens on an enterprise a level platform. So in that case, you need to have a centralized policy. So if you don't, maybe you miss out for some of the containers or the pod, it becomes again a risk. Inadequate logging and monitoring. Kubernetes actually gives you a feature to log what is happening, and this is something that is kind of in the runtime phase, where Kubernetes, while the runtime, you need to log and monitor if something is wrong, or there is suspicious activity or something. Broken authentication mechanism. Again, as Docker is providing an API, I showed you on the browser that you can access info container JSON. Here, Kubernetes as well has an API where it exposes its dashboard, and that dashboard should have an authentication mechanism. A lot of time, developers actually don't have an correct authentication. Maybe they use a authentication with their own ciphers, with their own cryptography. I have actually seen this. But what is recommended is you should use some kind of an OAuth, or you should use an authentication mechanism that is widely used by everyone. Missing network segmentation controls. This is again a case where I explained to you on the Docker, same scenario, right? So suppose there is I explained how two containers should not be able to talk if one is a crucial container having all the, maybe the database or passwords or stuff like that. So there should be proper segmentation, and this is a very important topic in Kubernetes. Um, whenever you hear network in Kubernetes, there would be something known as network policy, which is very important topic for Kubernetes, and it should be taken into consideration, where you know how to configure a network and what is the correct network policy that should be implemented. Secret management failures. So this is something where secrets, right? So as everything is going into a YAML file, you cannot add your username and your password to the YAML file itself, right? So there are several other methods. There are several vaults. You will have Kubernetes vaults, and that vaults will have different capabilities to store your secret, and then you can implement that in your application or your Kubernetes clusters. Misconfigured cluster components. Again, this is something that comes with if the thing that you're downloading, right? If the container that you're downloading is misconfigured and is not in a correct configuration. Outdated vulnerable Kubernetes components. This relates to if your main Kubernetes cluster, right? There are a lot of Kubernetes clusters that can be used. Kind of for an paid version, there are GKS that is managed by Google. There is EKS that is managed by Amazon, and a lot of other are there. On a deployment, on a development phase for practice and stuff, there is this single node architecture for Minikube. There is Kind, and these words that I'm saying, these are Kubernetes manager. So they take Kubernetes and which is an open source project, and they implement some of the other tweaks into them, and then they provide that platform to us. So outdated vulnerable components is where the middle person that you're using, or maybe the Kubernetes that you're using, is outdated, and due to the same and there's an CVE which is attached, and your data gets compromised. So this is something that covers most of the attacks that are there in Kubernetes. Uh, for Kubernetes demo, let's quickly again look at a simple web app, which I did show you again, which is running on uh, Kubernetes. I'll be showing you quickly on the terminal as well. So this is the YAML file. So there are two YAML files that are needed. There is a deployment YAML file and there is a service YAML file. Deployment YAML file will have these key pair values where you have the whole information. So image is something that you are fetching from the repository that I mentioned earlier. You can either fetch it from your Docker repository, you can either fetch it from your local repository. It's totally up to you. This is kind of the kind that are there. There are several other kinds. There is service, there is deployment, there is pod, and there is network configuration, and other stuffs are there. So you can see it over here itself, right? So for a service file, the kind is service. So what does the deployment YAML file do is, deployment YAML file will take care of the replica set, the one thing that I told you, right? So suppose that there are two containers that you are running, right? And for some or the other reason, the Docker, one of the Docker container maybe went on an error, or did not show up, or something like that. So for some or the other reason, it did not run properly. So what this deployment file will do, it will make sure that you are having two containers running for sure. Like once you delete it, it will again create a different one. Once you delete it, it will again create a replica of it. So it will make sure two replicas are running of your container. Again, service is something that is used on a network node to expose your application to the internet or to your organization. Service.yaml file are used. These are some of the commands that are useful for um, Kubernetes. So once you create the deployment file, you just have to type in this command kubectl. Kubectl is the kind of the API that we'll be using to again deploy a deployment or a pod or a service or kind of stuff. So this simple command will actually pull the image and make that Docker container running. So once you initiate this command is sent to the API server. API server, it then creates a controller, it creates a replica set, and then that particular things come to the kubelet, and kubelet is responsible for creating the pods and the container within it. So these are some of the commands that you should be aware of. Basic commands, it is good for the start. Minikube is something that we'll be using development for the Kubernetes. kubectl is again the software to communicate with the API server, and Kube-bench is kind of the software which is actually used on an enterprise level. So if you want to scan your Kubernetes, if you yourself have a Kubernetes, you can go with Kube-bench. There are a lot of other options as well. There are for Docker container, that there is Trivi, there are some paid one as well. But for an instance, if you want to do it on your local network or an internal network that your enterprise might have, Kube-bench is the option that you can go for. It is an open source tool and you can use it. So let's see the Kubernetes, right? How we can actually, how does a Kubernetes file look? I'll quickly go to the screen. And again, we are gonna navigate to ls. What do we have? So yeah, do we have this deployment.yaml, right? Let's look into the content of this particular YAML file. So see, this is the content of the YAML file, and this says, okay, pull the image from here, my simple web app. So if I just quickly show you the Docker images, if I just do a Docker image, you will see, yeah, my simple web app. This is the image that is already in my local directory. And what I have said over here is, hey Kubernetes, there is an image that I want you to pull from local registry. Don't go to the Docker registry that is there. I want you to pull it from the local registry that I have. Expose it on port 80, and this is the deployment kind, and there should be only one replica. I'll also show you how the replica thing works. So let's see what are the contents of the service.yaml file. Again, this the name can be anything, but the web app thing should match. This is something kind of a selector. How will a service.yaml file know that I have to attach to this particular deployment or this particular container? This is where the matching happens. So if you go to deployment again, you'll see that there's a match label web app. If this particular thing matches to the uh, service YAML, then this configuration will be valid for that particular deployment only. Uh, I hope that is understood. So there are several methods to expose. There is a node port method. There is cluster IP. There is a load balancer. For an instance where you are running it on a cloud and you want your application to be visible to all the users outside, you will be using a load balancer. This is something that is having a kind of, as I said, right, it is a huge, vast topic in itself. So let's see how we can actually deploy it. So what I'll be doing is we can just do a kubectl, and then you just have to apply, and with the file name that is deployment.yaml. Once you do this, this is actually unchanged. I did not change anything, and that's the reason it says, okay, we have already deployed it. So to see what are the pods that are deployed, you can just do a kubectl get pods. Once you do this, you will be seeing, I'll just minimize this a little bit to get everything in just single line. Yeah. So as you can see, this is something which tells us that our deployment is running. Our sorry, our container is running. So this makes sure that when I access this, this is actually accessible. When I reload this, this will actually help me get my application. There are a couple of more options. I'll also show you the replica set, the feature that Kubernetes have. So I'll just nano again and to deployment, and I'll be going to replicas, and I'll do three replicas. Okay, just for an instance, I'll save it, and just you have to apply it again, and it will uh, create the pods that are. So this will send a command to kubectl. Kubectl will then take care of creating pods, creating containers in that pod. So we can do a quick view again. Kubectl get pods, and see, you can observe there are three pods running right now. There are three of them running. So what happens if accidentally someone deletes it, right? So you can do it with kubectl delete, then the pod name, and then uh, the actual pod name. So we say, hey, delete this particular pod. Once we delete it, it says deleted. Okay. But if you do a kubectl again, if you do a kubectl get pods again, you'll see this is still there and it's not gone. So observe, if I delete this one, right? So if I delete it again, so XR941 will get deleted. Instead of that, what the Kubernetes will check is, oh, okay, this particular pod died off or was killed for some or the other reason, and I am instructed to host three replicas anyways. So what it will do is it will actually create a new pod then and there, and then deploy it again. So if you see again, you see this is still the same, but this is something that was newly added. So these are uh, okay. Yes, so no, this one was added. So you can see the status as well. So I got to know from here, container creating. So JJSKK is something that got created right now. If you do it again, it will show that the status is running. So these are kind of the main reason that Kubernetes actually attracts a lot of attention. Quickly, let us go to the demonstration. Um, I have a there's a just a sec. We'll be looking onto just one single demo, which is sensitive keys in code base. A lot of time, what happens is kind of how I showed you that you can directly, create a Docker file, and once the Docker is running, you can just keep in your Docker image name, and deployment will actually take that image and start running it. So what happens is sometimes we as developers or a engineer, what people do is they actually package things up, right? So to push it into GitHub or maybe somewhere else, we actually package this somewhere, right? We package it, and then we send it to commit or something like that. So there is this lab that we'll be solving. Let me quickly go to the port. So this is a vulnerable lab. I'll be sharing the link for this as well. And this is a very good place to start with Kubernetes and Docker security. It has a lot of uh, several scenarios, and how you can actually know it through with the OAuth top 10. It has multiple two scenarios for all the OAuths top 10 list. So see, it says build code. Welcome to the build code service. This service is built using containers with CI, CD pipelines, and modern toolset like Git, Docker, AWS, and more. So what happens a lot of time while packaging everything and pushing it to GitHub, a lot of times there are environment variables that needs to be taken care of, right? Environment variables should not be kept in the same container, or should not be there in the same scenario. So just to let you know what I'm talking about, so this is something that I'm talking about. So this is a Docker container that we are having, and what happens a lot of time while developers actually create a Docker container and deploy it, they deploy it with the commits that the code might have. What is commit? Commit is the change that you do in a application code, right? So this should be something like this. The build and configuration should be there. It should be, this is the correct way to keep it. Like you should have a different configuration file, and then you should do it. But what happens in a lot of cases, because maybe the credentials was previously there in the development build, and after committing, the credentials were removed. But what if the package thing, the environment variable or the commit information that was there in that particular package was not deleted, it was not checked, right? And this is where sensitive data gets stored in the code base. Let's quickly see how this can be done. So yeah, what we do is, first of all, just to understand, it mentioned, right, it has some Git or a Docker or something. So understand if there is an Git usage, or if this was done by Git, we can directly go to .git and config, which will give us a rough idea. Yes, there is a Git that was used. There is something that was pushed to GitHub. So what we can do is we can simply run a git dumper. Git dumper is a tool which will go and get all the heads, all the comments that might be done for that particular package. So we can directly do. I guess I have it. Uh, guess I have it. CD git dumper, yes, and we can do a Python 3. git dumper, and this, yeah, this is the host, and you can change this to whatever. Maybe let's keep it test. Okay. So what it will do is it will kind of try to fetch all the commits and all the hooks that are there, and it will save it in that particular test directory. So it has got some, these 200 says that it has got some objects. It has successfully fetched the data, and we are right now. Okay, this was done. So we can do an ls, and you can see on the uh, bottom right, there's a test. So you can just test, you can just go into test, and you can see what are the git logs. So once you do this, you get to know about what are the commits that were made or something like that. So see, there were 4 commits made, and what were the message on the commits? It was final release, updated the docs, updated the endpoints and routes. And here, this is something interesting. And just let me do it again. Yeah. Uh, Coming out from, yeah, so the last commit says, right, the last commit says included custom environment variables. This is the worst mistake that is done in Kubernetes, and a lot of enterprises applications still do it, that they store the secrets, maybe the key or all these stuff in directly the environment variables, and which is not at all uh, expected. So let's just get that commit uh, hash over there, and we'll check out what was the content, that was committed. So we'll do this, and now we are in a detached head mode. So if we do a ls over here, um, sorry, lsla, which will show you the hidden files and everything. So here you can see there's an environment variable. So what happened? The developer forgot to remove this, and the initial part, including this here, was not the correct thing to do. So you can just cat into the contents of env file to see, and here you go. You have the AWS key, the secret key, and the flag as well. So this is kind of the common mistake that is done in Kubernetes while configuring and packaging everything and sending it to the pods and the Kubernetes cluster. It is very important to see if there is any environment variable that you might have missed. This is also a separate topic for not keeping the environment variables on Kubernetes. Instead, as I mentioned, there is Kubernetes vaults that are used. There are several other secret managers that are used to store this sensitive information. I hope this is kind of clear, and let's hop on to the presentation. We are almost done. So yeah, this was something that kind of grabs an attention and actually helps you take a dive into Kubernetes and Docker. This is something that is evolving very fast and should be taken care of. Let's quickly go through this real case scenario. So there was this Kingsing old school hack. So that there was this executable, Linux executable, which was actually sent to the Kubernetes clusters via Postgres SQL, and a lot of Kubernetes containers were affected. What happened was these guys used to send this malware to a lot of containers which were maybe unauthenticated, maybe had a misconfigured Postgres SQL. What went wrong was they started using all those. So it gave access directly to the system. It gave access. It gave a remote code execution. What this would do is this would help the crypto miners use those all containers as their botnet. So kind of they were creating a network of all these Kubernetes clusters and botnet, and that was used for crypto mining. This was something that was on a very large scale. The second thing that over here is active Kubernetes RC attack relies on unknown open metadata vulnerabilities. So this is again, as you remember, I mentioned earlier, there were CVEs which weren't patched, and big companies were using it. WebLogic is something that was vulnerable. It is again a very vast thing to go again. But this is something where a misconfiguration resulted in this RCE attack, and uh, um, a lot of enterprises were affected. So this is something that should bring you to why should you learn Docker and Kubernetes security, and why this is an interesting topic. Red Hat conducted a survey of 600 DevOps engineers from across the globe, and what they found out was 42% of the enterprises are actually not fully prepared and doesn't have capability to actually kind of handle these container security. They don't have these also this might be something that you might be hearing for the first time. So there are a lot of enterprises application there are still vulnerable, which is again a very good place to start and have a skill build up with. Also 67th of the respondent, when they were asked why did the deploy the development or the production was delayed, it was due to not having correct knowledge about the security risks, which again the application is made, staging is ready, and then again it comes back for some or the other error or something like that. So this is the correct time. It is never too late. It is the correct time to start with Docker and Kubernetes security. We have a couple of blogs that are coming up for this as well. I would highly recommend Kubernetes Goat. This is kind of the GitHub repo, Kubernetes Goat. You should surely visit this. This is something that was developed by an ex-bandit of Payatu. This is kind of a vulnerable application environment that is built up, and you can actually go and practice and scale up yourself for uh, Kubernetes. Security and Docker security. Um, I hope this is it. Hopefully, I was clear on all the points. And yeah, Aparna, over to you. Thank you so much for everyone joining.
Okay. Guys, the session is open for the Q&A. There are some questions already in the chat box, Samuel. I request you to go through it.
Yeah, definitely.
And in terms of recording the session, we will be posting the recording of this session on our digital channels, guys. So we request you to keep following Payatu on every possible digital channels. Yeah, Samuel, over to you.
Yeah, Ravi, your question is, do you have anything that breaks down this top 10 vulnerabilities into proper test cases and possibly how to test and mitigate them? Yeah, this is kind of the test case. If you go through the OAuth's top 10, there are a couple of test case. I have some of the things to share as a test case where you know how to test, what to test next. You can absolutely go with Kube-bench. Kube-bench is a proper tool which will actually show you what security got misconfigured, because these are configuration changes, and these configurational changes, you going and testing them each one by one would maybe result in a very longer this thing, right? You won't be able to maybe cover all the things, or maybe you might be missed out of something. So there is this tool, Kube-bench, which you should be using, which has all the things to cover, which will test your environment with the Docker daemon being set, if it is exposed or not, if the correct port is added or not. All these things will be kind of shown over there. As well as I do get your question, and you can connect to me on my Twitter. I'll be sharing you some links for the test cases for this. Uh, yeah, Rahul Thakur, again, Kubernetes Goat. Thank you, Sunil, for adding in the link. Kubernetes Goat is a very good place to start testing and start going around. Also, if you don't want, kind of go to a place where you wanna maybe Kubernetes playground. If you don't want to set it up on your machine, there is a playground for Kubernetes. Yeah, this one. Just a sec. If you can see my screen, this is kind of a playground. It will take a couple of minutes, to uh, kind of, I'll just accept this. It will kind of give an error first, but keep going on. So see, this is something that it will give you a 4 hour of kind of an instance where you can create multiple Docker containers, and it will help you understand how things correlate with each other. This I'll be dropping this, just a sec. I'll drop this link in the chat. With the lab, with the Kubernetes Goat lab, this is something that you should be uh, practicing on. Just like Burp Suite for scanning web application, is there any such tool for auto scan through the containers? Yes, Mubin, there is a tool which I already mentioned. Kube-bench is a tool which is open source. You can absolutely get it on your system, and I'll just show you how it works. So you just have to be in the directory. You just have to cube uh, bench, I guess. This was it. Just a sec. Kube-bench is a correct tool that you should be looking at. This is kind of a tool which will also, there are some paid one as well. You can just Google it, and yeah, Trivi, thanks. So Trivi by Aqua Security is also that I mentioned earlier. What is the name of the lab to practice Kubernetes code? Thank you. Could you please tell me how I start Docker security from scratch? Katika, Mohsin, I would highly recommend you to go with the fundamentals first to understand how Docker is working. There is a YouTube channel. I'll be I'll be telling you just a sec. Abhishek Docker. This is not from a security perspective, but to get onto a security perspective, you are highly recommend to go through this videos that are there. I'll pinpoint what you should be looking at. Yeah, this one. This is not just one video, it is kind of a series of everything that will help you build a very strong fundamentals in Docker as well as in Kubernetes. Abhishek, what's the name again? It is yeah, Abhishek Varamala. This is the guy. You should check him out on YouTube. Uh, I guess. Is there any other question? How to move from beginner to intermediate in Docker and K8s security, as currently most resources I use are intended for beginners. Shubh, I would recommend you to first go through the fundamentals. That is really important. And this is something that would come with practice. There is this other lab with Cube which is called Cube, I guess. Uh, just There are a couple of more labs that you should be practicing on. There is on also a Pawn lab. You can visit there. They also have a kind of a good resource for learning and maybe solving Kubernetes and Docker security. Pawn lab is something that you should be looking at. First of all, my recommendation would be get clear with the fundamentals, because this is something that is evolving very fast, and fundamentals is something that you should be aware of. You should be aware of what is network policy, how isolation works, how pods are deployed, how these things are working. You should be aware of. So yeah, this is also one of the things that you should be looking at. KubeGoat. From the assessment perspective of a web application having backend Docker and Kubernetes, what all assessment do we have to do at different level, internal organization as well as external? So on an external note, one of the things that I forgot to mention, how can you kind of, get to know if if the backend is Docker or Kubernetes cluster. A lot of time there are headers. Look for headers where there might be, a mentioning of a pod, which pod to communicate. This is usually done for networking. So look for headers, look for errors. Errors might indicate that you are using that the backend is using Docker or Kubernetes. Also, on an internal note, you should be looking at the CIS benchmark, right? CIS benchmark is something that also you should be taking care of. I'll be adding that link as well. Benchmark for Kubernetes. CIS benchmark is something that an organization or an enterprise platform looks at. These are all all the settings that should be in place. What is the intended setting and what is a vulnerable setting? They have it all in place. You should be looking at this on an internal note. On an external area, you should be mostly focusing on networking. How you can, maybe as I showed you, right? There are a couple of attacks where just by an exposed Docker daemon, the whole Kubernetes cluster gets, compromised. So you should be from an external node, work mostly on the networking part of how you can connect to different nodes and how the networking is working inside. This is something that you should be doing from the external point of view. Sorry, I pasted the wrong link. Just a sec. Kubernetes CIS. Yes. Yeah, these are couple of very good documents that you should be referring to. Any more question, guys? Any good suggestion on paper or article where these threat attacks are discussed? I would recommend. It was on DEFCON, yeah, DEFCON videos on the same. So there are a lot of people actually researching about this and coming up with new vulnerabilities, coming up with new papers. I would highly recommend you to go on YouTube, Dipanshu, and there are videos on DEFCON, NullCon, and people have delivered great sessions over there where they have found new ways to exploit Kubernetes and Docker. Thank you so much, Ravi. Thank you so much. I hope this adds value to all the participants and uh, you have this skill set with you to get into Docker and Kubernetes because in the coming years, if you have this on your resume, not just on your resume, but in your skill set that you are aware of Docker and Kubernetes security, that will be a great add-on to your skill set. Sunil, again, what are the latest technique uh, through which Docker is utilized for malware or bot sharing? Yeah, again, this totally depends upon the configuration. There is no kind of a latest technique. Uh, this is something that a configurational changes can convert the whole Docker cluster into a botnet or a malware system. So the last was King that we saw Kingsing, which was the latest. It happened around last to last year, I guess. It was in 2020 or 2022, I guess, last to last year, I guess. So yeah, it totally depends upon the configuration. Suppose I'll give you an example. Latest technique, if you see, one thing comes to my mind. So suppose I create an image and push it to Docker Hub. Okay. Once I push it to Docker Hub, suppose as I mentioned as well, suppose my built image is actually having a reverse connection or has potential to actually get me reverse connection access to your particular pod or your cluster, that becomes very crucial, right? There are kind of 10,000s and 20,000s of downloads. 10 to 20,000s of downloads of a vulnerable instance of a vulnerable images. There are, if you search for I'll share an article. You can get in touch with me on Twitter. There's an article where they have listed out all the images that were vulnerable. And these vulnerable images, when you actually pull it and use it on your own, that system is now affected. And imagine if this is done on a scale where enterprises are using this on a very large scale. They use the same image to maybe host 10,000s of containers, right? And that will make a very a huge drastic disaster, right? For this same thing, Docker also has something called as image scanning, which does what it does, it scans the image that you are maybe pulling it from the registry from your local, or you're making it on your own. It will make sure that the components that you have compiled together are secure. This is called as image scanning in Docker, and this is also a very crucial part in the Docker security.
I guess that's about it, Samuel. Um, Thank you, everyone, for joining this session. And thank you, Samuel, for delivering such a valuable and a wonderful session. I hope you guys have a great weekend ahead. Thank you all.
Thank you, Aparna. Thank you, everyone, joining in. Thank you so much. Have a good weekend. Bye.